So with great apologies to those who watched this video before, you only have to watch this first part. Well, I guess you could watch the second part as well, but when we change slides, it's different. This apparently, for some reason, did not get uploaded originally. I totally hit the wrong button. Sorry. So in this problem, related rates problem, what we have is we have the hallway, which I've sketched out here beautifully. It's W across, so W is depends on your particular numbers. And we've got this angle theta that controls where the camera's pointing. So in our case, the camera's going to point starting way over here to the far left. And what's going to happen is this, where it's pointing is going to move across the room here. And what it is we want to figure out a formula for theta that tells us how this moves across the room. And if we look what we're given, one of the things we're given is we're given how fast we can move along the wall. And what we're told is we can move along the wall at S. That's a very bad looking S there, not a 5. So it's not 5, S meters per second. And what we want to do is we want to relate this to theta. So that is S tells us how fast we can move along the wall. And what we need to do is we need to come up with an equation that relates these things. So what we need to do is we need to relate our angle theta, the fact that we have W, and that we know how fast this side is changing. So a good thing to do is what we can do is we can label as X our current distance sort of from the middle there along the wall. So X controls how far away we are from the middle of the hallway. So what we need to do is we need to find a formula that brings together theta, because we want to know about theta. We want d theta over dt. That brings together the w, because we know what w is, it's a constant, and x, because x will tell us how far our distance is, and we know how fast it changes. So really the key here for this related rates problem is finding that formula that connects all three of these things together, theta, w, and x. Now, as a hint, I would tell you that we have done some homework problems related to these. Definitely a lot of them involved triangles, but otherwise you can also figure it out from what we have here. Once again, if you have any questions, please let me know, and sorry for the people who watched this video already. The rest is the same. This was the only thing that changed. So what I'm doing is I'm making a video here to give a couple hints, hopefully, so it'll help you figure out how to get started on this problem. So hopefully in part 1 you figured out how to set up your related rates problem so that you end up with the fact that the derivative of tangent of theta is equal to some number we'll call m for now. And your goal in this problem, of course, is to figure out a formula for theta so that you can move back and forth. That is, your camera starts pointing over here to the far left, moves all the way to the right, stops here, turns around, and moves all the way back. So, because we want to be able to sort of, monitor this hallway. So in part of step 2, one of the hints I gave you is that there's a way to undo the tangent function. And what you're going to end up with is you're going to end up with the fact that tangent of theta of t is equal to m times t plus some constant. And what this is going to help you do is it's going to help you, in fact, build a piecewise function that controls how this camera moves along the wall at any time. So you're going to input time, and you're going to get out the tangent value along the wall. Not an angle, but instead the tangent. And so it's going to have two pieces. One piece looks like mt plus c. One piece will look like nt plus d. And there's also going to be the times what we want to allow this at. And so what we want to do is we're going to start by starting at time 0. And this piece here will be the idea that we want to start by facing the far left side of the wall here. So we want to start way over in this corner and sweep along the front. And that's what this first function is going to control. It's going to make sure we want to start it at the far side and move all the way to the right side. So we're going to use this function from 0 equals t up until some other value. Let's call this value k. I don't think we've used that letter yet. And then next, what k will do is will tell us that then what we want to do is we want to use our other piece of our piecewise function up until some other time frame, and this bottom function is going to tell us that we want to start facing the far right and moving all the way back along the wall. So in order to figure out this c value, what we need to do is we need to probably figure out what this means. So what it means is we know we want the tangent at time 0 to equal some number so that our tangent value actually points over here. So you're going to have to figure this out. This is going to be a number, and so let's just give this number a name for now. Let's call it Q. So what this Q value is, this is the Q value so that you're pointing in this direction. So that tangent of your angle points over there. You don't need to figure out the angle, but you should be able to figure out Q from your diagram. Once you find this, what you can do is you can say, well, I know that I need Q to equal tangent of theta of 0, which needs to equal m times 0 plus c, and that'll help you figure out your c. The next step, after you found this, this will tell you your c value. The next step is going to be to figure out what times you want to look at. And since as part of the problem you're given how fast you move along the wall, using that you can figure out how long it's going to take you to move across the wall to figure out your k value. So this will be based on your speed. The last thing to do is to figure out what d needs to be. And again, we're going to figure this out by thinking about the fact that there's a certain value that we need tangent of theta to be at time k, so that we're pointing at this far end of the wall, and this needs to be the value so that n times t plus d starts in the right location. That is, we want to make sure it starts over there. And the final hint I'm going to give you is that m cannot equal n in this case. They're not going to be the same numbers, but they will be related. They should be pretty closely related to each other. Because the key is that m controls how we move to the right, and n needs to control how we're going to move to the left. So these numbers will be closely related. They won't be exactly the same, but you need to make one number so that you're moving to the right at a good speed, and the other a certain number so you're moving to the left. Now, this might not answer all of your questions on the project. As always, just come and see me. I'm available quite a bit, so come and ask questions or ask in class. But hopefully this gets you started and in the right direction. Thanks.